Hi everyone, welcome to the new video. Today we'll see day 4 of Terraform tutorial series. So let's go. Day 3 of Terraform tutorial series, we saw that how we will define the variables in variables.tf file, how are we going to, refer it in main.tf, what are the types of variables that we can use in Terraform, how we can override the default values of variables using .tf word file, how to define output block in outputs.tf. I hope things are clear till here. Now the day 4 series contain Terraform state deep dive. In this we'll understand what is Terraform.tf state, what is local versus remote state, what is state locking and consistency, how to inspect state by using Terraform show and Terraform state list command. So Terraform tf state file. By Terraform tf state.tf state file, we mean if this file is not created manually, this file is created automatically by Terraform when we do our first Terraform apply. So whenever a fresh run or a fresh project we create of Terraform, and after the fresh Terraform apply we run for the first time after running Terraform uh, init, then we run Terraform uh, plan, then we run Terraform apply. After we run Terraform apply, whatever resources we wanted to create using main.tf in our cloud portal, that things get stored in terraform.tf state file in a JSON format. So in a JSON format, the resources created by Terraform get stored. So it is the ultimate source of truth, because how will Terraform remember that you created resource and you went after 3 days, again you came back to the same script and you tried running the script again? So how will Terraform remember that you added some line of code again? You already created EC2 instance earlier. EC2 instance, by EC2 instance I mean VM. Now you want to create an bucket. S3 bucket is for storage, which is used in AWS. It's a storage resource and you want to create. Now you added some piece of code in main.tf and you want to create only S3 bucket because your instance is already running. How will Terraform know it? That you have already created an instance and you just have added the piece of code for the uh, S3 bucket, and uh, that you want to create. So scenario is that already we created EC2 instance. Now we have to create AWS3 bucket. Now what's the problem? Somebody in your team manually deleted the instance that you created through Terraform, the EC2 instance. Now, how will Terraform know that the thing that was done manually, Terraform is not aware about it? How will Terraform know that EC2 instance which was created earlier is now deleted, and even if we created the EC2 instance, it is not existing there. So even if we have just added a S3 bucket code in main.tf, but we need to recreate the EC2 instance again and S3 bucket also. Both of the things are required now. How will Terraform know? Terraform will know it through Terraform TF state file. It is the ultimate source of truth, you can say, for Terraform. It will, when you do Terraform apply again, what it will do, it will match the things which are there in terraform.tf state with actual cloud resources, and it will check that whatever is mentioned in terraform.tf state, is it there or not. Now Terraform will compare that whatever is existing in terraform.tf state and whatever is existing in actual infrastructure, whether it is matching or not, and it will find that EC2 instance which is mentioned in terraform state, it is not there in AWS portal. So when we do terraform plan, then there only it will show that the EC2 instance is not present, and in terraform apply it will create that resource again. So this is how terraform tf state help us, and that is why terraform tf state is important, to keep a track between what is actually present and what we have made in the code. That's why this is why terraform tf state comes into picture, and this is a demo terraform tf state file, that how it stores the value, like whatever uh, ec2 instance it will create, how it will store the value, how it will store the type, how it will, it stores a value and everything in the json format. And so that whenever there is a match, it matches everything, the name, the ip, the type, everything, so that there is no mismatch with the actual and the code present in the uh, repo. Now when we have covered the what is terraform.tf, what is local versus remote. Now local versus remote means when the state file is stored in locally, because when we run it in our repo, so when we run from our repo, or when the code is in our repo, and we run terraform, now terraform's tf state file is stored in our uh, lab, in our changes. It's stored locally, it is not. Whereas if the same code is used by the other person in their uh, os, in their system, they will have their own terraform.tf state, right? So that is when that which what we call as local state. What we mean by remote, when we have terraform.tf state file stored somewhere at remote location, or you say a centralized location, where everybody who is um, in centralized uh, location. So whenever any developer who is using the same piece of code, a same terraform.tf state is there, which is maintaining everything, and there is no clashes. Because you understand that if there are multiple terraform.tf state for the same code for each developer, there will be clashes and there will not be a consistency. Like there will be no track that whatever resources are created, what we have added, what we deleted, what the other person added, what we he deleted, nothing will be in track. So that's why a terraform.tf state file, when stored in a centralized location in a secured form, uh, that is when it is called as remote. Why is state locking and consistency important? Suppose, say again, I am telling a scenario that suppose a person who has who is using the same piece of code, and the other person also using the same piece of code, and terraform.tf state file is not stored um, in a central location. So a person created one developer, suppose a developer created a EC2 instance, and a B developer deleted deleted the EC2 instance. So there will be again the clashes. The consistency is not maintained. Maybe if both the person are working on the same cloud with their piece of code, the terraform.tf state consistency will not be there. Okay, when both the person, the cloud is same. Okay, the cloud is same, code is different because it is being stored in their repo. Code is same but used locally. So there will be clashes, that if somebody deleted and somebody, and at the same time both are doing changes in the same piece of code. So think about the GitHub. Why GitHub came into picture? So that there should not be a clashes. Somebody is working, he added some changes, and other developer also added some changes. So there should be not any conflict that other changes were missed, and in this way there are, changes. We need to do git pull before making any changes. We need to first see what all changes we have to add, what all changes we have to push. We need to resolve git merge conflict if any issues are coming. Similarly, that's why terraform.tf state should be stored in a centralized location. Next thing is, so before that, I want to show you that how we can store the terraform.tf state in a centralized location. Either we create, so for storing the terraform.tf state in a centralized location, we are using S3 bucket. That's a secure storage which we use in AWS. S3 bucket is a storage, and we use it for versioning purpose. And S3 bucket, because S3 bucket can store multiple Terraforms file, TF state file, but with versions. And that's why Terraform S3 bucket is used. So now you'll be wondering that why for state locking and maintaining consistency we use only S3 bucket and DynamoDB, where and this can also be achieved in Terraform Cloud. It is already there, but when we don't use Terraform Cloud, we generally use S3 bucket and DynamoDB. Why? S3 bucket is a centralized location where our terraform.tf state file will be stored centrally and save, and it also helps to maintain version. So if we have to roll back, or if our terraform tf state by any reason gets corrupted, we can roll back to the other previous version. We can move the changes, or do the changes. Why DynamoDB is like a reference, or you can say a table, a database, which helps everything happens in key. So when one thing is getting edited, the same key cannot be edited at the same time by multiple people, because the key should there is a same key. So when two people are editing the same key at the same time in a table, that cannot be possible. There will be a state lock. So other person will not be able to do the changes for the same state file if the changes are already happening. That's why DynamoDB, because it's a kind of a database, and Terraform state will help. It's like a key to that DynamoDB. So how to do it? We can either do it through Terraform only. I'll give this reference to this GitHub repo, that how to, there is a main infra and then the backend setup. So basically we have to create s3 .tf. I'm creating, and in main.tf So I have been creating the AWS S3 bucket, and the bucket name I have to give force destroy true. Then versioning we can maintain, because to enable versioning, because it will be good if we have to roll back. So as I said, resource, then the resource that we want to create, and the name that we want to give to refer in the Terraform only. Similarly, we can do encryption too if you want. So this is just for so that nobody can easily see the content of our terraform.tf state. Then in DynamoDB, we need to create the DynamoDB table, the name of the table, and this is the log ID, billing mode, and this is the attributes of the table. Name is log ID and type is S. So this is the attributes of the table that we are going to create. And uh, then the provider.tf, basically this is also one thing that whatever we mention, the provider we mention, this is a plugin that we mention already in main.tf, we can mention it separately in provider.tf also. And output.tf, in output.tf we'll get the value of the bucket name, because that we will need, and the dynamodb table name, because that will also we will need. So after that, whatever we have created, the name that we have created, the bucket and the DynamoDB table, that we need to give in our whatever main.tf, the main infra. There we need to give that in which backend. So basically, it is referred by backend. That a terraform.tf state file should be stored in a backend with S3, and the bucket name is what the bucket name we'll get from here. The key will be a path to the Terraform TF state file where it will be stored in bucket. The region, because S3 bucket is created in one region. Then the DynamoDB table, which will be doing the state locking, and encrypt is true. So this is how the main.tf, or this is just a setup that you can do it uh, first before your main infra run. So you have to do this first. After creating the S3 bucket and the DynamoDB, you need to provide the details in the main.tf or provider.tf. You can provide in main.tf, as I have given in the other repo. You can provide those details in main.tf too, and that will tell Terraform that you have already created a centralized location for storing the terraform.tf state, and there only your terraform.tf state file gets stored. So this I have taken from Code Cloud, the free lab. And here, if you'll take a free lab of 1 hour, you'll already see that there will be a main.tf, and there will be some challenges that you need to do. And I've already did Terraform in it, so it has, uh, given me that created the directory, loaded the plugin. Now I did Terraform plan, and then after that I did Terraform apply. So it is asking for me that whether you are sure you want to create it or not. So I have to give yes. The prompt come, and then the apply is completed. And as soon as the apply has been done, you can see a terraform.tf state file is created, and it is stored like a JSON as I showed. This is a JSON, and in main.tf there was just a file name and content which was there to be shown. So after this, if I do terraform show, so this is how it will show the current state, that how it was, what all we created, and what is the content, sha, everything. And terraform state list, if I so Terraform show will show that whatever is maintained in terraform.tf state, whatever data is there, it will show that. And Terraform state list will show that what all, it is maintaining local file games. So that's why it has given just one resource that it is maintaining. So these are the two commands that I wanted to show, and thanks to Code Cloud. You can also try the free lab of Code Cloud. for your practice. So that's all. That's all for today's video. I hope it's helpful. Please let me know your views in the comment section. Till then, take care. Bye.